Hi guys, when we do multiplying radicals or divide radicals, we have two rules. We went over this in the other video. In multiplying two radicals like this rule here, nth root of a, when you multiply by nth root of b, the answer is you keep the radical, nth root, you multiply the inside, a times b. It's only could be done, as you can see over here, when these two indices are the same, like square root and square root, cubic root and cubic root, fifth root and fifth root, and so on. Also, we can do the opposite. If I have nth root of two factors, nth root of a times b, I can separate them. I can do nth root of a by itself times nth root of b times self. So I'm going to have some examples on this. The first example here, we want to multiply cubic root of 5 times cubic root of negative 16. Oh, over here we have negative inside the cubic root. But that's not a problem because the index is odd. So all what we do, this negative, we can take it out later. But it could be done. If it's square root or fourth root or eighth root, it cannot be done. So since they have the same index, I can keep that index and the radical, and I just multiply the 5 times the negative 16. So 5 times negative 16 is negative 80. Because this is cubic root and over here we have negative, what we can do, we can take that negative out. So now it's negative the cubic root of 80. Now we need to simplify cubic root of 80. So we are going to do the 3 factorization. 80 is 8 times 10, or any way, or any other way you want to start it, it doesn't matter. We're going to end with the same answer. Then we factor each one, the 8 and the 10, because neither one, the 8 or the 10, is divisible by 2. So we can divide 8 by 2, we get 4. 2 is prime, 4 is not. We can divide 10 by 2, we get 5. 2 is prime, 5 is prime, so now only this 4 is not prime, so we factor this into 2 times 2. Over here, we want to find cubic roots, so you want to group them in groups of 3s, like 3 similar numbers. So here is 3 2's like this. And this is going to be 1 2 outside the radical. So 1 2 outside the radical, and don't forget that we have negative here from before. Is there any other groups? Actually, this 2 has no other 2's, the same with the 5. So now what's going to be inside the cubic root is going to be the 2 times the 5. And we are done with this problem. Okay guys, here's another problem. We want to simplify square root of 2 multiplied by the square root of 6. Both of them are square roots, so I can multiply the inside. Keep the radical as it is, a square root. There is invisible 2 in here, and then just multiply 2 times 6. So it's radical 12. Now we try to simplify the 12. We know that 12 could be factored into 2 times 6. 2 is prime, 6 is not, but 6 could be factored one more time to 2 times 3. 2 is prime, 3 is prime. This time we're doing square root. There is invisible 2 here, so we want to group them into groups of 2's. Like, I don't mean number 2. 2 members in the group, 1 2. Then we take out the root 1 2, so that's going to be equal to, and this 3 is miserable, it doesn't have another 3, so that's going to be inside the root. So it's 2 square root of 3, and we are done. Here's another example. Example C, we want to multiply square root of 70 times square root of 14 times square root of 22. All of them are square roots. Index 2, index 2, index 2, but it's invisible. So now we can multiply the inside, but actually if I multiply these big numbers, it's going to be like huge number. So now I can show you another way to do it easier. I see over here 70. So the first thing as factor is going to pop into your head is 70 is 7 times 10. So now I'm going to put them all inside one root, but I'm not going to multiply them. I'm going to do the opposite. I'm going to factor them. It doesn't have to be to the prime factor, because I notice here this is 7 times 10, and I notice here that 14 is 7 times 2. So now this 7 is repeated twice, so I can group them together. So that's 7, this 70 is 7 times 10, times this 14 is 7 times 2, and this 22 is 2 times 11. So actually 11, 2, 7, 7, all these are prime factors, except the 10 is 2 times 5. So you can factor this 10 again, or just keep it for now. Now I have 2 7s, so that's one group, so I can take 7 outside, times, here's another group of 2s, so I can take 2 outside. We don't have another 11, we don't have another 10, but even if we factor the 10, let me write it here first. It's going to be 10 times 11. Even if I factor the 10, it's 2 times 5. 2 is prime, 5 is prime. We don't have any other 5s, we don't have any other 2s. So actually, even if I factor it, it's not going to help. So all what I do now, just multiply 7 times 2, you get the 14, the square root of 110. I think that's going to be easier than multiplying all these three numbers and get a very big number, then start to factor it like this. All right? Here's another example. We want to multiply square root of 14 times the quantity of square root of 35 plus square root of 56. If you remember, when this is addition and we have multiplication outside, we call that distributive property. You have to distribute the square root of 14 to the square root of 35 and multiply it also by the square root of 56. So it's going to be square root of, since the square root of 14 has index 2 and 35 here inside the radical, which has also square root or index 2, we can multiply them. We keep the square root and we multiply the inside. 14 times 35. Same thing, plus, we write plus. Then we do square root of 14 times square root of 56. Both of them are square roots, so are same radicals. So I can keep the radical and multiply the radicands, which is the inside. So it's 14 times 56. And instead of multiplying 14 times 35 and get a big number and then factor it, well, I'm going to try to use the same idea I did on the previous example. I'm going to factor the 14 into 2 times 7 times the 35 is another 7 times 5. So now I have 2 7s, because I need to group them in 2s, like 2 members, because over here it's invisible 2. So 2 7s, I can take 1 7 outside, but this 2 and this 5 stays inside as 2 times 5, which is 10. 14, same thing, 2 times 7, 56, 7 times 8. Here's another group of 7 also. So I can take 7 outside. So now I took this 7 outside, and the 2 times 5 is 10, stays inside the square root. Over here I have 2 7s also, so I can make a group of 2, because the square root I need groups of 2s, and I can take that 7 outside. What's gonna be left inside the radical? This 2 right now, I don't see another 2. and this 8, I don't see another 8, but if I multiply 2 times 8, I'm going to get 16, and we know that 16 has a square root. What number times itself gives you 16? 4 times 4, that's right. So now I'm going to write over here 7 square root of 10 plus 7 times the answer of the square root of 16, which is 4. Don't put the 4 one more time inside the radical. All what I need to do is just multiply 7 times 4, which is 28. So it's 7 square root of 10 plus 28. These are not alike. There is no radical 10 in here, so you can't multiply them. So that's your simplest form. Okay?